Hi there, Jose here from Effex. Today I'm going to explain you how to select an experimental design for a screening situation using the platform. First, I will tell you a little bit more about the catalog of Omar's design that we have in the Effex platform. Then I will state the problem that I will solve with the demo, and I will choose an Omar's design for the problem stated. Omar's designs stand for orthogonal, minimally aliased response surface designs. On the left-hand side, you can see a color map on a 4-factor Omar's design, and you can see the orthogonality properties. So first, the main effects are orthogonal to each other, and then they are also orthogonal to all second-order effects, so they can be estimated independently from each other and independently from all second-order effects. And it's a response surface design because you can estimate partial or complete second-order effects model. At the platform, we have a large catalog of Omar's designs. We mined hundreds of millions of designs and selected the best. Currently, there are around 500,000 designs in the Effex catalog for quantitative and two-level categorical factors and blocking factors. If you like to do screening, you have at least two goals. First, you want to detect active main effects. So you need a high power to detect them and orthogonality between those and the second order effects. So you can really distinguish between the effect of the linear effect of a factor and an interaction or quadratic effect where that factor is involved. Second, you want to detect the most important second order effects. So you need a high power to detect the two-factor interactions and quadratic effects. You also would like to have a high projection estimation capacity. What is this concept? This gives you an idea on how good the design will be for optimization, because with Omar's designs you can do screening and optimization at once. Additionally, you would like to have a minimum maximum fourth order correlation, and all this while staying within budget, so at a minimum run size. So you should be able to study the trade-off between the attributes and the size of the design. What is a projection estimation capacity, or PEC? Say that you are looking for a screening design for 8 quantitative factors, and imagine that you have found a design that has a value of the projection estimation capacity for a second order effects model, which is denoted as PEC and SOE in brackets, equal to 3.8. What does that mean? That means that using that design, you can fit a second order effects model on any subset of 3 factors out of the 8, and also on 80% of the subsets of 4 factors out of the 8. That means that if you will have a few effects that matter, so in the presence of effect sparsity, a high value of the PEC attributes makes it possible to use a single Omar's design for screening and optimization. The problem statement. We are a company that builds garden sprinklers, and we are researching the next generation garden sprinkler that you can see on the left-hand side. That's a scheme where you see the 8 different parameters that we can play with to design our garden sprinkler. Those are different angles and different diameters and thicknesses and so on. Each parameter has some settings, so has a range where they can vary, minimum and upper value. They are all numerical, and in the end we would like to use it for screening to see what matters, but also for optimization to get the best factor values for the most efficient garden sprinkler. So there are 8 quantitative factors. The budget is limited to 26 tests because one test in this case is one prototype, so means building one garden sprinkler, and the goal is screening and optimization at the same time. Let's turn into the software now and see how we can solve that design selection problem. This is the homepage of the software where we have access to the catalog search, which is the feature that we are gonna be using today. We click on catalog search, we open the filters and specify that we are interested in designs with 8 3-level factors. Our budget was limited to 26, so we are going also to impose a constraint there, 26. We apply filters and we obtain that there are 3,394 designs. On this part, you see a graphical representation of the distribution of different criteria, like the replicates or the number of tests or number of center points and so. And we're going to look at the graphical filter. On this graph, each line from left to right is one design, so there are more than 3,000 of those lines. Each vertical axis is one of the quality attributes of the design, which is the first one is the number of tests, then the number of center points, replicates, and so on. And it's a very interactive graph, so you can move things around. You can see also the trade-off between the different criteria and the design size as well. And this is exactly what we are gonna do. We're interested in screening and optimization, so we are interested in designs that they have a high value for the PEC. So you see that asking for high values of the PEC already leaves out designs that they have 21 runs or less. Just as an example, to have a reference, definitive screening designs, they have a value of PEC equal to 3 unless you go to definitive screening designs with more than 30 tests. So the catalog of Omar's designs improves what is out there for a screening experiment. Next thing you will look at is the maximum fourth order correlation. Why? Because a high value for this attribute will make modeling very difficult, because you could not distinguish what is coming from which effect. So from 3,000 designs to 200, but we can do it better. So we can ask for high power to detect interaction effects and a high power to detect also quadratic effects, even higher. So we allow only powers more than 0.5. That leaves us with designs with 24, 25, and 26 tests. We can apply graphical filters, and because we have less than 50, we can click on the table and go to the Pareto analysis. Again, Pareto analysis is where we can compare designs with each other easily and make our final selection. While other software may give you a single design as a solution to your problem, we provide a platform to help you making a decision. And how we do that? Well, this Pareto analysis has two different parts. The first is a graphical interface, and then we have a table with each design. In the first part, we have two sections. So here is where the graphs will appear, and here is where you select what matters for you. Number of runs, always important. In this case, projection properties, important, PEC. If you select 2, you will get a scatter plot with the Pareto points. Pareto front will be colored in red. With any combination of attributes that you select, you can get a recommended design, in this case, design number 3. If we keep selecting, we will get different representation. So maximum fourth order correlation is important, but also the power to detect interaction and quadratic effects. We click on Get Recommended Design, and design number 19 is recommended in this case. So we have design 19, and just to remember, before we were recommended design number 3. So we are going to compare those two designs with each other in order to make our final selection. So we are going to deselect them all. We're going to show more designs here, so we can select them at one. Excuse me. Yeah, to select, we have to click on the checkbox. We click on the checkbox of number 3 and number 19. And now, yes, we go to side-by-side comparison. Side-by-side comparison is where we can see the properties of the designs next to each other. So you see design number 3 is substantially smaller than design 19, but it has higher maximum fourth order correlation. If we would like to see where is that happening exactly, we can go to aliasing and look at the color map on correlation. So you see that the high value of the correlation is happening here. We can zoom in. We can see that that is happening between interaction effects. They involved different factors, so actually 5, 6, 7, 8 with all the combinations. So that is where the high correlation occurs, equal to 2/3. If we will see the color map of the other design is much better, but is also 2 runs larger. So this is a decision that we have to make. What is our trade-off? Let's look at projection properties. In projection properties, we will check the second order effects model, and we see that with both designs we can fit all second order effects model on 4 factors. So those 2 designs are very, very good, and they provide high chances to do screening and optimization at once. So design number 3, design number 19, the cost of the experiment may be of very important. So in that case, you may decide to go for design 3. So you have some spare tests to build, garden sprinklers, and confirm your results. So you can go back, you can go to design number 3, click anywhere on the row, then you will get the design details of that experimental plan, and you can download the design. You need credits to do that or to have a project activated. You can continue, you give a name, garden sprinkler demo, and then you are directed to the download page where you can specify the values for your factors, so the name and the lower and upper level as we have done before, and you can download your design in a CSV or an Excel format. This ends the demo of how to choose a screening design. If you have any questions, please reach out to effex.app, and otherwise see you at the next video. Ciao.